now we can state some characteristics of exponential functions of the form f of x equals b to the power x. We can, of course, write that as f of x equals b to the x. And here we have a couple of graphs. Okay, here's one function where b, the base, is greater than 1, and here's another where it's between 0 and 1. The domain of f of x equals b to the x consists of all real numbers, the interval from minus infinity to infinity, and the range of f of x equals b to the x consists of all positive real numbers, that is, interval from 0 to positive infinity, not including 0. We have a horizontal asymptote, which is actually item 6. 2. The graphs of all exponential functions of the form f of x equals b to the x pass through the point 0, 1 because f of 0 is b to the 0, regardless of our base, which is equal to 1. And as long as b is not equal to 0, which we've stated it can't be. Therefore, the y-intercept is 1, and there is no x-intercept. Again, there is a horizontal asymptote. If b is greater than 1, if our base is greater than 1, f of x equals b to the x has a graph that goes up to the right and is increasing on its entire domain. The greater the value of b, the steeper the increase. If our base b is between 0 and 1, not including 0 or 1, then f of x equals b to the x has a graph that goes down to the right, and it's a decreasing function. The smaller the value of b, the steeper the decrease. Number 5, f of x equals b to the x is a 1-to-1 function, and it has an inverse that is a function. Number 6, the graph of f of x equals b to the x approaches but does not touch the x-axis. The x-axis, or the function y equals 0, is a horizontal asymptote. And I would expect that you would look at that graph and see that all these things do in fact match.